Objective 9.7, Solving Rational Equations. In Objective 9.7, we want to be able to solve rational equations using two different approaches. In the first approach, we will be using the LCD, and in the second approach, we will be using cross-multiplying. So here's our first example. We want to solve the equation 4x plus 1 over x plus 1 equals 12 over x squared minus 1 plus 3. We're going to break this down step by step, and so I suggest that that's the way that you really focus on these problems, is to really get these steps down, because this is how you'll do any problem, any equation where you're trying to solve using the LCD. So step 1. First, we need to find the LCD, and we'll do that by factoring all of our denominators first. So in this particular equation, x plus 1 cannot be factored any more than it is, but x squared minus 1 is a difference of squares, so it can be factored. So we're going to rewrite that as x plus 1 times x minus 1. And now we can tell from the denominators present that our LCD should be x plus 1 times x minus 1. Then in step 2, we're going to rewrite all of the terms in our equation with that LCD. So we originally had our first term on the left side as just 4x plus 1 over x plus 1. Now we need to multiply by x minus 1 on both the top and the bottom so that we get our LCD in the denominator of this first term. The first term on the right side was already 12 over x plus 1 times x minus 1. So since it already has the LCD, we don't need to do anything more to that term. But the last term on the right side was just the 3. And so if you think of that as 3 over 1, what that means here is that this 1 that we would imagine being there has to be multiplied by both the x plus 1 and the x minus 1 factors. And so if we have to multiply by both on the bottom, we also have to multiply by both on the top. Okay, so this is what our equation would look like with all of our terms rewritten with our LCD. Then in step 3, we're going to multiply both sides of the equation by that LCD that we found. Okay, and what that does is that when I multiply the x plus 1 and x minus 1 on this side, those factors are going to cancel out. So x plus 1 cancels out, x minus 1 cancels out. We're just going to be left with the numerator. On my right side of the equation, since I'm adding two terms together, these factors, this x plus 1 times x minus 1, that's going to have to be distributed to both this term and to this term. And so when I distribute it to both of them, each time we're going to be canceling out the factors that are in the denominator. So the x plus 1, x minus 1 will cancel out these, and then x plus 1, x minus 1 will cancel out these. So what we're really left with then is just the numerators as our equation, which kind of makes sense because in order for this to be equal, now that we have a common denominator, it's all going to depend on what happens with these numerators anyway. So in step 4, we cancel out all those denominators, and we're just going to be left with the 4x plus 1 times x minus 1 from right here equal to the 12 from this numerator plus the 3 times x plus 1 times x minus 1 in this numerator. And then for step 5, we're just going to solve that equation. So now that the fractions are out of the way, we're just going to simplify, FOIL things out, distribute numbers where we need to, and then solve accordingly. So you can see in this case, I'm FOILed these two factors to get 4x squared minus 3x minus 1. I also FOILed these two factors to get the x squared plus 1. Then I distributed the 3 here, so that gives me 3x squared minus 3. And now when you look at what you have without any of the parentheses left, you can see that we have x squared terms here. So this is probably going to be quadratic, which means we need to solve it in a quadratic fashion. And with quadratics, we usually solve by getting everything on one side of the equation equal to 0 on the other side. So that's what we've done. I've subtracted the 3x squared here to get x squared. There's no x term on the right side, so negative 3x stays as is. And then the negative one I had, I'm going to subtract a 12 and add a 3 to that to get negative 10. So now I've got x squared minus 3x minus 10 equals 0, which can be factored into x minus 5 times x plus 2. And so my actual solutions, the values that x is going to be equal to, are going to be a positive 5 and a negative 2. Now, we're not quite done. We need one more step, and that step is to check. This is vitally important with rational equations. You must check your answers because there's a great likelihood that there's going to be extraneous solutions. So if we check the x equal to 5 value, we take our original equation. Remember, we always go back to the original. So we take the original equation, substitute 5 every place where we had an x, and then work things out. And so our term on the left side of the equation becomes 21 over 6. The first term on the right side becomes 12 over 24. And then we still have that plus 3 on there. So 21 over 6 is going to simplify to 7 over 2. The 12 over 24 simplifies to 1/2. And then when we simplify those, we end up with 3.5 on each side. So 5 checks out. It does work. Now let's check out x equal to negative 2. We go through the same process. Every time we have an x in our equation, we're going to replace that with a negative 2. That's going to give us negative 7 over negative 1 on the left, which just becomes 7. On the right, we're going to get 12 over 3, which just gives us 4. And then 4 plus 3 also gives us 7. So negative 2 also works. So we have two solutions to this equation, and both of them really do work. Okay, so 5 and negative 2 will be our final solutions. Let's take a look at another one quick. We're going to go through the same steps, but let's go through them a little more quickly this time now that we're a little more familiar with what we need to do. So in step 1, remember we need to find the LCD, and we do that by factoring all denominators if we need to. Well, in this case, our denominators are just an x minus 2, and they're the same denominator. So we don't really need to do any factoring, and it's pretty simple to see our LCD is going to be x minus 2. So now we rewrite all of the terms with that LCD. So that means our term here with 5x over x minus 2 and the term here with 10 over x minus 2, those stay the same. They already had x minus 2 in the denominator. We don't need to mess with those. All we need to change was that 7 that we had in this place. And so we'll multiply both the top and the bottom, because remember we're thinking of this as 7 over 1. So we're going to multiply both the top and the bottom by an x minus 2. Okay, so we've rewritten all of the terms with the LCD, and then we're ready to multiply both sides by the LCD. So when I multiply everything by x minus 2, that allows me to do my fourth step, which is to cancel all the denominators. And so what I'll have left is just the numerators to create an equation. 5x equals 7 times quantity x minus 2 plus 10. And so now that's the equation I'm going to solve. So first I start by distributing the 7. So 7x minus 14. Then I can combine the negative 14 plus 10 to get negative 4. And then I'll solve for x, and I end up with x equal to 2. Now, for my final step, I'm going to check x equal to 2 by putting it back into the original equation. And as you can see, when I do that, I end up with denominators of 0, which means I have undefined terms in my equation, and that's not going to be allowed. So since x was the only value I came up with, x equal to 2 is the only value I came up with, and 2 does not seem to work in my equation, my final answer is going to be that there's no solution. Now sometimes you can kind of get a mix of the first and second example where you get two values, like we did in example 1, and maybe only one of them does not work, but the other one does. So in that case, you need to make sure you only list the one that works as your final answer. All right, it's your turn to give it a try. Solve this equation, 3x minus 2 over x minus 2 equals 6 over x squared minus 4 plus 1. Pause the video for a moment while you work things out and come back to check your answers when you're ready. All right, so I'm not going to show you all the work to this one. I'm just going to give you the solutions, which should be -3 and +1. They should both work, so both of them need to be listed as solutions. If you're not getting those solutions as your answers, please make sure to ask about it during class, or just go back over and check over your work to make sure you've done all your arithmetic correctly. But if you're still not sure after you've done the check, ask about it in class and I'll try to get you back on the right track. Now let's go through one more type of example, and in this case we're doing a little different approach. We're going to use cross multiplying because this equation, when you look at it, is a special case of rational equations. This is a case where we have a single rational expression on the left equal to a single rational expression on the right. So if you look back at the other examples we've done so far, we've had more than one rational on one side or the other, more than one term on one side or the other of our equation. And so in those cases you need to use the LCD. But in this case we just have a single rational expression here on the left and a single rational expression here on the right, and those two are equal to each other. So when that happens, we can work this like a proportion, and we can actually use cross multiplying as our method for solving. So when I do that, my 2 times the x minus 1 gives me one side of the equation, and then the x squared minus x times 1 is going to give me the other side of my equation. And it doesn't matter which is on which side, as long as 2 times x minus 1 is on one side and 1 times x squared minus x is on the other side. And again, what this does is it eliminates the fraction form in my equation and makes it something that's a little easier to work with. And so now I'm just going to solve this equation. I distribute the 2 to get 2x minus 2. I don't really need to distribute the 1, so I'm just left with x squared minus x on the right side. And again, because we're now looking at something with a quadratic term in it, I want to solve it as a quadratic, which means moving everything to one side and making it equal to 0. So I end up with 0 equal to x squared minus 3x plus 2, which factors to x minus 2 and x minus 1. And when I go to check these answers, The 2 is going to work because this will be 2 over 2 squared, which is 4, minus 2, which is 2. So 2 over 2 is 1. And a 2 here would also end up giving me 1 over 1, which is 1. So 1 equals 1, that works out. But if I put 1 in for my x, then I end up with zeros in the denominator, and therefore the 1 cannot be part of my solution. So x equals 2 is my only solution to this equation. Okay, so why don't you give one a try just to make sure that you understand what we're talking about here. Again, pause the video for a moment while you work and come back when you're ready to check your solutions. All right, so if you take the 3 times the x plus 4 here, and make sure you distribute that 3, and then the 1 times the x squared plus 4x here, and then solve the equation that you end up with, you should end up with a solution of x equals 3. Remember to check the answers so that you are not including extraneous solutions in your final answer. X equals 3 is the only value that is actually going to work in this equation. All right, so that should give you the information you need to be able to solve rational equations. Now remember, with this objective, you actually have 2 practices that you're going to do. So you're going to start with the 9.7a practice, and once you are finished with this practice, I want you to tell me so that I can check it over before you do the 9.7b. It's really important because I want to make sure you're on the right track with 9.7a before you continue to work on more problems in 9.7b. Okay, so once you've done the first part, make sure you have me check it over. And when I've given you the okay, then you can work on the second part with 9.7b. The major difference between these two is that 9.7a actually divides up the practice into telling you these are problems with the LCD approach, these are problems with the cross-multiplying approach. Whereas in 9.7b, you just are given a bunch of equations and you have to decide which approach would work best. Okay? Otherwise, it's just a lot of good practice to make sure you understand how to solve equations. Once you do have both of those practices finished and have them checked off your list, then you're ready to start preparing for your final quiz. Remember, we've changed this a little bit. So the final quiz is only going to be over the final 4 problems of practice quiz 9b. So if you look at problems 9 through 12 on that practice quiz 9b and work through those problems, those are the kinds of problems that will be on the quiz, and that's all that's going to be on the last quiz. Okay? And then once the quiz is finished, you can work on reviewing the entire chapter and preparing for the chapter test. All right, so if you have any questions about any of this, or you're just unsure about anything from before the break or since we've come back, please make sure you ask about it in class so we can get everybody up to speed again and keep rolling to finish up Chapter 9. And we'll see you next class.